Okay, so we're going to start chapter 5 today, and it's going to be all about, this whole chapter is going to be about solving a system of equations, which is why I gave you guys the bell ringer I did, because in a system of equations, you're going to solve for one of the variables first, and then you're going to take the variable that you solved for, you're going to plug it back in, kind of like what we did on our bell ringer, in order to figure out what the other variable would be. So we're going to start off with kind of like a review over how you would do this with a system of two variables. If you just have like an x and a y, you can use substitution, you can use elimination. You could also use graphing, but we probably won't spend a ton of time on the graphing side of things. But we might address it a little bit. But we're going to spend more time working with substitution and elimination, because then eventually we're going to get into the three variable stuff, which you would have done also last year in Algebra 2. You would have solved equations that have three variables, like an x, a y, and a z. And we'll talk about the different ways that you can do that, okay? The first thing is just to kind of go over like what this means and what it represents on a graph if you were to find the solution to a system of equations. A system just means you have more than one equation that you're working with in your problem. And again, like I said, these ones that we're going to start off with today will have two variables. Most of the time we use x and y, but really it could be any two letters that they want. In the past, you've learned how to use substitution and elimination, so we'll review that. But when you solve something, if you get x to equal like 3 and you get y to equal 5, we would write our answer as an ordered pair, 3, 5. And what that ordered pair means or represents is if I were to take those equations and graph them, that's the point where they would intersect and cross at perfectly. So when you're finding a solution, even if we don't have it on the graph, it would be there on the graph if I were to go put the lines on there and see where they cross. That's really what you're looking for. We will talk about the situations where you can't find an ordered pair, or there isn't an easy way to solve it, or if you get the same equation more than once and then you actually have an infinite number of solutions. So we'll talk about all those situations as well. A linear solution is just a system of two lines, because we'll also see cases later in this chapter where I take a line and I have it mixed with like a circle equation or a parabola, and we kind of see what those look like because they change a little bit on what they mean as far as where your solutions would be. When you have a linear system, you can have two situations. You can have a consistent solution, or you can have an inconsistent solution. Consistent means that your lines would intersect at a point, so they would cross, make like an X on the graph. Inconsistent means that they would not cross. They would be parallel to each other. And we've talked a little bit about inconsistent and consistent solutions in the past. First thing that they want you to do is figure out, if you're given a system of equations and you're given a point, like a possible coordinate, they want to know if this would satisfy your equations, like be a solution or not. To do that, you're going to take the ordered pair that you have. So like on this first example, they're giving me the ordered pair 1, 2. I need to take that and plug it into both equations. So I'm going to put the 1 in for the x and the 2 goes in for the y. So they took this 2x minus 3y equals -4, and they're writing that down here. So they took 2 times 1, because 1's my x from up above, minus 3 times 2 from my coordinate up above equals -4. And then they did the same thing with the second equation. You took 2 times 1 plus 2 equals 4. So these numbers in here, I'm just going to highlight them. These all came from the ordered pair up above. That's where they're getting those 1 and 2s from. All right, so let's finish these off to see if they actually balance. That's all we're really checking for right now. If it balances on both sides, that means that it's a solution. If it doesn't balance, then it's not, okay? So if you do this one on the left, 2 times 1 would be 2. And then we have minus, this would be a 6 equals -4. Is 2 minus 6 -4? Yes, so that checks out. Okay, that's good. On the other side, you'd have 2 plus 2. Does that equal 4? It should, so it checks out again. That means that 1, 2 is a solution. So I'm going to go ahead and just underneath this, I'm going to write solution. Or you could say yes. But 1, 2 works for both of these equations because it goes in and it balances it out on either side. Now, if I had gotten something that said like 5 equals 4 when I do the math, that's not true. So then we'd have to throw out that and say it's not a true solution. Maybe it's on the line somewhere, or it could just not even be a part of the system at all. Okay, why don't you guys try the example at the bottom of the page. See if 7, 6 is a solution of that system of equations. It's not a solution. Okay, so I just went and plugged it in. Did the left side work? Yeah? You got -4 equals -4 here. Okay, so that checks out. But then what did you say happened over here? 20 trying to equal 4, which is not true. Okay, because that causes a problem, we have to say no, or I'm just going to write not a solution. Okay, I want you to just think about this for a second. Did I change the equations on you guys? No. Okay, if lines intersect, how many times are they going to intersect? If I draw 2 lines and they cross, 1 time. So if I already found a solution, are there any other possible solutions out there? No, there's not. Okay, so when you find the 1, like, you're done. Your answers are only going to have 1 ordered pair that works when you're talking about linears, like linear equations. Because when you have 2 lines, they're always going to cross in some situation like this. You're going to have these lines that look something like this, and they're going to cross right there. So that would be the solution that we had up here. That would be like 1, 2 on my graph. So since I already found the solution and I didn't change the equations on you guys, any other combination of points that you put in there aren't going to work for both. They might work for one like we saw, but they're not going to work for both of them. Okay? All right, let's turn the page. So now we're going to get into solving linear systems. So they're not always going to say, here's a possible answer. It's also not conducive. Like if I gave you 2 random equations and I said, find the solution, it's probably not a good idea to just start guessing and checking random points and seeing what works. It would take you forever to probably land on the one that actually is the true solution. So we have ways to simplify this so that we don't have to spend all this time guessing and checking. So we're going to start off with substitution. And how you use substitution is you'll have 2 equations. You need to solve one of them for one of the variables. It does not matter what equation you use or what variable you solve for. I always look at my equations and I just try to figure out what's easiest to get by itself. So if an x or a y has a coefficient of 1, so there's no number in front of it, that's usually the easiest letter to try to get alone. And you want to just move everything to the other side of the equal sign. So you want it to say something like y equals blah, 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 or x equals whatever, okay? Once you get it solved for, then you start your substitution process. You're going to plug that quantity in for the other equation in place of that variable that you solved for. What that will do is it'll get rid of the double variables. You'll be able to solve for whatever other variable you have, and then you can go back and find the other answer. So if I have these 2 equations, 3x plus 2y equals 4, and 2x plus y equals 1. This is my system I'm working with. I want to find my solution. Using substitution, I want to solve for one of the letters. But remember I said earlier, I try to find the easiest case. So because the second equation has just a y, do you guys all see that? That's what I'm going to solve for. I'm going to take this one and I'm going to solve it for y. Really, you could choose either one. You could solve for the y on the top, or you could solve for either of the x's, but solving for the y on the bottom is going to be the fastest way to get this done. And I'm not going to have to really work with too many like weird numbers like fractions, decimals, and stuff like that. So I'm going to avoid that if I can. So to solve this for y, I just need to move this 2x over, and so all I have to do is subtract that. And so I get this new expression, y equals negative 2x plus 1. Now we're going to start our substitution. Now when you substitute, you need to go into the other equation that you haven't touched. You can't go back into the same equation that you did because it won't work out for you. Stuff will start to go away and you'll be kind of stuck. So you want to take this expression 2x plus or negative 2x plus 1, and we want to plug that in for the y up on the first equation. And that's what I have written down here for step number 2. So I bring down the 3x plus 2, but instead of writing a y, I'm going to replace it with the negative 2x plus 1 because we solved that for y, so I should be able to plug it in. It represents the same quantity. And now that I look at this, I don't have any y's anymore. I only have x's. It makes it easier for me to solve for x now. So that's what I'm going to do. First thing I should do is probably distribute to get rid of these parentheses. So if I distribute here, what does it say? Okay, I want to get x by itself. So what's 3x minus 4x? Okay, and then I have plus 2 equals 4. What would you do next? So I have negative x equals 2. Divide by negative 1 because we can't have a negative letter. So x is going to be equal to negative 2. Okay, you solved that. Now we're going to use that. So coming down here to step 4, we're going to take our x value and we're going to go back to our original equations. Again, it doesn't matter at this point which one you go back to. We're going to plug in our x in order to help us solve for y. So would you guys like to go back to the first equation or the second equation? The first one? Okay, so the first one says 3x. So I'm going to do 3. Instead of x, I'm going to put in my negative 2 because that's what I solved it for. Plus 2y equals 4. Now we're going to solve for y. What is this going to look like? Okay, what would you guys do next? Add 6. We have 2y equals 10, so y is 5. Okay, so how do I write my final answer here? Good, negative 2, comma 5. Okay, if you wanted to go back and you wanted to check your solution, you could. It should satisfy it though, but this would be something maybe like on your test or like on something that's a bigger, like more high stakes than just like homework. If you're wondering, did I solve this correctly? Like, did I get the right solution? You could plug it back into those 2 equations like we started out with today. Make sure that they both balance out. That would be a really easy way for you to check your work and make sure you got the right answer. All right, I would like you guys to try this one. Use substitution to solve that system. All right, I'm going to start working through this here. What equation did you guys solve a variable for? Did you use the top or the bottom? The bottom, and you solved for x. That's what I would have done first. So if you rewrite this, it says x equals what? Good. If you said -3 plus 2y, it does not really matter at this point because we're just trying to solve for one of these variables. So then I'm going to take this whole quantity, this 2y minus 3, and I'm going to plug it in for x on the other equation. So it's going to have to follow the 5. Okay, you distribute here. You should have gotten 10y minus 15 minus 4y equals 9. You're going to combine like terms. So I have 6y minus 15 equals 9. What would you guys do next? So that would be 24.
Mrs. Anderson,
Yes.
I'm Sherry with TCC. You were not
Problem.
She paused.
I paused to accept my award. Okay. What does y equal? 4. Okay. And then when you guys plugged that back into either equation, what'd you guys get for x? 5. Which one did you go back into? Top or bottom?
Dude, class is over in a minute. What's in the box?
Oh, we'll open it up. We'll open it up. All right. So 5, 4. All right.